the One-Off Technology Podcast with your host, Roy Richardson. Each week we cover topics in the news and how they affect you. Sit back, relax, and open your mind. Hey everybody, welcome to the One-Off Technology Podcast. My name is Roy Richardson. I am known in some circles as a tech troublemaker. And tonight, I'm going to tell you something I know nothing about, which is my favorite topic. Anyway, so there's been a lot of announcements this week. And by the way, we're going to cover quantum computing. We're going to talk about time crystals. We're going to talk about Chrome and two-factor authentication. We're going to talk about YouTube Premium Lite. And we're going to talk about a stupid Apple trick that uses Google search. I don't know. I like these kind of things. Maybe you do too. So we'll get started. We'll get talking about it. So first topic of tonight is, what the heck is quantum computing? No, seriously, what the heck is quantum computing? So, oh, look, my big fat head's in the way. So we'll be playing a game of Where's Roy's Head? And we'll just keep playing this. So what is quantum computing? And what the heck is a time crystal? I'm glad you asked. This will be a much more interesting show since you did. So, I want you to think a little bit. I want you to think of a haystack. And this haystack has all the straw needles in it. And imagine, if you will, we had a metal needle somewhere in that haystack. How would you find it using a computer? So let's talk about that. So, oh, look, Roy's fat head is again in the picture. So let's move Roy's fat head out of the way. So we'll keep playing this game. It's fun. So with your classic computer, the computer that you are, your cell phone is a computer, by the way. In case you didn't know it, it is. In fact, your cell phone, any cell phone you have, has more power, computing power, than the computer that sent the space shuttle up the first time. Not kidding. So anyway, computers with their chips, they work in binary. They work in ones and zeros. Basically, that means on and off. And so it takes all those bits, that on and off. And let's say, for example, one of these letters, literally right here on the screen, is, let's back up one. Previous, all right, right here, the letter W. So imagine there's 8 bits, 8 ones and zeros that make up that letter and make that present. So in a classic computer, it takes a bit and it makes that, of course, actually 8 bits would be a byte. And we'll talk about it. And things are either true or false, or on or off in a binary world. And if I take 8 more bits and add them, that means I've doubled the number of bytes I have. So 8 bits, 16 bits would be 2 bytes, that type of thing. But quantum computers are totally different. Quantum computers use quantum bits that are called qubits. And so they're made of quantum particles in nature, basically atoms. And a lot of quantum computers use phosphorus or aluminum atoms embedded in silicon. And qubits, here's where it gets crazy. Qubits are 1 or 0 or both at the same time. You're saying, what? Wait, so they're on, they're off, and they're on and off at the same time? Yes, basically. So each time you add a new qubit, you increase capacity exponentially through a process called superposition. Okay? And so my fat head's in the way again. So we must move my fat head out of the way. There we go. So with a classic computer, you would have to examine each straw needle in a haystack one at a time. So the computer would have to literally take the straw. You'd have to label every straw piece and have to load it into memory and individually go through each straw piece looking for the metal needle somewhere in that haystack. That's how a classic computer handles it. But with a quantum computer, again, fat head in the way, with a quantum computer, you need an entire, you could load the entire haystack into processing, and it potentially could quickly determine where the metal needle is, where the steel needle is inside that haystack. It's all about capacity, and we'll talk about that next. All right, so superposition, and again, playing the fathead game. Where's the fathead gonna go? No, up over here. Hey, thanks for watching me over here. See me over in this corner? Okay, pay no attention. Look at the stuff of, oh, sorry. Look at the stuff over there. Over there. Oh, no, seriously, over there. Don't look at me. All right, well, maybe look at me, but anyway. So superposition is the fact that with qubits, it's 1 and 0, and 1 and 0 at the same time. Imagine it's both true and false, and also true and false. Basically, if it were a coin toss, if you flipped a coin, heads or tails, the coin is just spinning without being either heads or tails. It's literally just spinning, okay? Just spinning. It's just spinning. Spinning, spinning, spinning. Oh, anyway, I digress. And, oh, fathead again. Fathead alert. Da-da-da, da-da-da. We'll put it here. All right, so the process that allows you to combine all these multiple qubits, and each new qubit exponentially increases capacity. So think complex, super complex math, 10 to some power. And here's a pro live streaming tip for you. This is a pro live streaming tip. Never do math live. You will not get it right. You can't add 2 plus 2. I have no idea what 2 plus 2 equals right now, because when you're live, you can't do math. I think it may equal 5, but I think I have to use larger values of 2 in order to accomplish that. I could be wrong. There's some pi in there or something, pi r squared, but everybody knows pi's are round. And then there's the whole cheesecake thing. So is cheesecake a cake, or is cheesecake a pie? I don't know. I would eat a square cheesecake. I will also eat a round cheesecake. Well, no, I'd eat the cheesecake. I wouldn't eat around it. So, point being, don't do math live, ever. All right, so big head alert again. Sorry about that. Let's move the fat head up here. Hey, I'm over here now. All right, so a quantum computer, because of the data sets to calculate things like think, for example, weather forecasting, or let's say the shipping company wants to calculate where all of its ships are in the world, like the really giant ones, like Exxon, for example, with all those oil tankers and supply ships and everything. They want to know where all their vessels are at any one time. And then, you think an oil company, Exxon is now an energy company. Just be aware, they're not an oil company anymore. They're an energy company. So they want to use the minimum amount of energy, and they want to take the most direct route possible to send their ships around the world to the different places they have to be, as well as keeping track of where they are. That would be a really, really, really big data set that is just too big for a standard computer. So you can say, but wait a minute, they got those supercomputer things, man, those supercomputers, and they load up all that data. Well, even then, they have to load the data in kind of chunks. So at no point are they really able to process everything all at once. And a standard computer, because it doesn't have all the data at once, takes a long time to process all that data. Just a long time. So currently, we use standard computers, and it takes a lot of computing power and a lot of time. So theoretically, quantum computers could do these calculations faster. Right? Now, but a classic computer will continue to be needed. Fathead alert. It's not as bad as other times. My head's not near as in the way as it. There we go. Is that better? All right. So, but we'll still need classic computers for gaming. We'll still need anything that still uses good old-fashioned ones and zeros, like I was talking about the image of that letter, the ones and zeros that make up that letter. Well, it'll still be going on like that. That is the ones and zeros that make that letter. And so most data files are simply ones and zeros arranged to form the information. So standard computers will be the way to go for the foreseeable future. We won't be buying quantum computers for a home anytime soon. It's just not going to happen. Plus, they're really, really expensive, and we'll talk about it later. Now, while I'm on the topic, I want to talk about this. I would really love, and there goes fathead alert. Gotta move the fathead out of the way. I would love it if you would subscribe to my channel. So if you are rewatching this and you're not currently a subscriber, subscribe and ring the bell so that, hey, you'll know when I do my videos. That bell will notify you and say, hey, Roy's got another video out. You should go and watch it. Really. You should. You really, really should. And then the other thing I want to tell you is that I get excited when you leave comments or ask questions, because that means we're like communicating together. It's like we're an audience. Everything is good, man. It's good to see you, good to see me, and we're just talking about things and trading ideas and making the world a better place by collaborating and being a community. So I really appreciate that. So just want to tell you that. And then the other part is I am a semi-social creature. I'm out there on Twitter and YouTube, on Facebook as Tech Trouble MKR. Again, I couldn't buy enough vowels to make it the whole thing of Tech Troublemaker on Twitter. So I said, okay, fine. I'll be Tech Trouble MKR on Twitter, and I will just do the same thing on Facebook for consistency. So follow me out there. A couple of you already sent me direct messages that way. Great. I love talking to you guys. I love connecting with you. So feel free to connect with me that way. And again, if you're watching a rewatch of this, thank you so much for watching it. I really do appreciate it. So, all right, on with the show. All right, so now here are the downsides. Big head alert. Da-da-da. Get over there. Right there. Right there. Right there. Nope. Stay. Quit. Stop. No. Quit moving. Stay. I tell you. Okay. There it is. All right. Fine. So the downsides of quantum computing. So, well, your gaming computer uses a lot of power, but you could do water cooling, but you got the 1,000-watt power supply. That holds nothing compared to a quantum computer. Quantum computers use lots of energy and lots of heat. So most quantum computers are super cooled because more qubits mean more heat. IBM, for example, when they built their supercomputer, had to build a super fridge around it and to cool their quantum computer. So it's 15 millikelvins, or negative 459 degrees Fahrenheit, or for my friends who aren't in the U.S., negative 273.135 Celsius. Wow, that is really cold. If your food came out that cold in a restaurant, I am sure you would send it back. I'm sure. But quantum computers have to be that cold in order for all the magic to happen. All right, so what is a time crystal? Again, fat head alert. My fat head's in the way. Let's move my fat head up here. What do you think? There. All right, so what is a time crystal? See this right here? See this picture right here? Well, that wasn't a time crystal. And again, fat head alert. All right, fine. Go down here. Will you stay there? Okay, there. So that wasn't a time crystal. Yeah, that was actually a picture of glass breaking when I hit a storm door. Hit my storm door with a rock that was thrown by my weed trimmer. Wow, that was a neat trick. Zoom back in. All right, here we go. And let me play the video for you. Watch this. Wow. So here is, so I did my weed trimmer and I hit a rock and it hit the storm door. And literally because of the safety glass in this, it was breaking really, really, really slow. It was actually quite a trip. So yeah, it was tripping me out. Anyway. All right, so point being is somehow I have to get my world back to normal size. Wow. And this is what happens when magic happens. If you have a magic mouse, let's talk about this. So if you have a Magic Mouse, there's a cool thing where you do tap tap and it will zoom in. And that's really helpful when you need it, but it's not very helpful when you don't need it. And now's one of those times when I don't need it. But remember, live is live, and so things happen. And so let's try our luck in making a change here. So I'm gonna change out scenes, and I'm gonna do the presentation. And there we go. I made it work. Hey, magic! I'll have to go back and fix it later. Whatever made that craziness happen. But anyway, and it zoomed in. Why did you zoom in? Anyway, stop the zoom. Stop the zoom. This is getting really crazy, isn't it? There we go. Normal size. Okay, quick. I'm going to quit clicking on things. So anyway, that wasn't Time Crystal. Also, it's not something out of Doctor Who or Star Trek. It's not. Time crystals are not. But, so let's think about phases of matter. Water, ice, solid, gas. When something is in a phase of matter, they're at their lowest point of energy or activity. Okay? And, oh, fathead alert. Let's go move the fathead. How about this corner? There we go. We'll put the fathead there this time. All right. So, with time crystals, the qubits have been captured in a state that's essentially a different phase of matter. For my science geeks, basically this bends the second law of thermodynamics out of shape. So here's a fun buzzword that right now probably means nothing. Time translation symmetry. It's when a time crystal is both stable and changing all at the same time. Well, why not, Roy? You told me that, the qubit was basically like a coin, heads or tails, just spinning, never choosing heads or tails, and yet being heads or tails all at the same time, all the time. So, yeah, there you go. Well, heck, I don't even know what a time crystal is, but it means something, and a lot of university scientists and Google are really, really, really excited about it. Okay, fathead alert. Hang on. Moving fathead. Here. How about here? Does that work? Yeah, that works pretty good. All right. Imagine a room full of ping pong balls, and they're all bouncing around like all crazy, and after a while, they've bounced for so long that somehow they wind up going into a pattern. And it just gives it, maybe it's a figure eight or maybe something, but they're constantly moving, but yet they have formed a pattern. And this pattern is stable because they're still moving, but they're moving in a consistent way. So this is essentially what a time crystal is. And I'm sure science is going to prove me wrong, but that's essentially the best way I think could boil it down, is that it's kind of a moment when all the qubits are doing their work, but you've reached a point of stability with them, and it kind of freezes that point where that's happening. And again, with the zoom. All right. So, wow. I got to figure out where the zoom's coming from. Zoom, zoom, zoom. Do you hate when things happen? There we go. All right, cool. I'm doing something with my mouse tonight that's different than what I normally do. Anyway, so seriously, what does this mean? So the goal of the time crystal was to exhibit stability rather than constant spinning, and the time crystal seems to allow it. And while the scientists are all excited, they don't even have a practical use for this yet. But I've got to think that it gives you predictability, and predictability is an amazing thing in science. It's, the scientific process, being able to repeat something over and over and over again. So there you go. That's what a time crystal is. So going all the way back to the beginning, we take the qubits, we put them together, multiple qubits to give us more exponential capacity to be able to take large data sets, to upload them and do processing, and the quantum computers with all the qubits, which are phosphorus atoms being manipulated with waves and that type of thing, lasers, and basically it's able to do this crazy computing on weather forecasts or weather patterns to try to determine where hurricanes may be or where tornadoes may be, and it does it so much faster than our best supercomputers, and it's able to figure out ships' paths. And then here we have the time crystal, which is an attempt to kind of find a way to take a snapshot of stabilization of the change that's constant within qubits. And so, yeah. And why do I want to explain this to you? Because it's in the news, it's going to be big, and you're going to be able to say, Roy told me about that first. Yeah, he didn't know what he was talking about when he said it, but Roy told me. He did. And so, I want you to get excited about that because, hey, that's going to be good to know. Now, more tech news. We're going to get started with some tech news. We'll call this Chapter 2, for lack of a better thing to call it. Why not Chapter 2? And Big Red's in the house. Hey, Big Red, thank you so much for stopping by. I appreciate it. We're just having some fun tonight talking about quantum computing. Well, we need to all go out and get our quantum computers so we can edit video. No. Standard computers are going to be around for a long time. Quantum computers are going to be theoretical, mathematical science type places where big data sets need to be processed in a more timely manner than standard computer chips can. So, yeah. Next, I want to talk to you about two-factor authentication and Google Chrome. So, Google is working on and is currently testing out a way to do two-factor authentication using the Chrome mobile browser on your phone. So basically, you would log into a website on your computer, and then you would get notification on your phone in your Chrome browser, and then it would give you a code to type in to authenticate you. So instead of you having to wait for a text message, that type of thing, it would be a way to do it. They already have some of that kind of happening now with a separate app, but now they're looking to turn Chrome into being that app. Currently, the Google Assistant app on your phone, if you have that, is where it currently does that. And will pop up and say, hey, is that you? Are you logging in? Yes. And the problem is, though, it doesn't consistently work on an iPhone. Works great on Android. But so this is, I think, Google's way to find a way that's more neutral between devices, where if you got Chrome, you got Chrome, you got Chrome. It works. And so this can be really cool. I'm excited about that. Next, I want to talk about YouTube Premium and YouTube Premium Lite. So Google also is testing out a new feature. So you may not know this, but if they have a subscription service called YouTube Premium, where you get to watch music videos and you get it without ads. You don't see any commercials, and you also can, so like one thing I hate about iPhones is that if you're watching a YouTube video and you try to change apps, it doesn't keep playing the video, it stops. Well, if you have YouTube Premium, you get the feature where it keeps playing the video, or it keeps playing the music if you're doing YouTube Music. Okay, that's cool. I like that feature. I'd like to have that feature, but not enough to pay money for it. Just give me the ads already. I can live with that. And then also you can download videos from YouTube for offline viewing, most videos anyway, not everything. And then you have access to YouTube Originals, which, by the way, if you have YouTube TV, you also have access to YouTube Originals. Why don't I get any benefit there for YouTube TV to get ad-free on YouTube? I don't know. Maybe one day. But the point being is that they're now looking at something called YouTube Premium Lite. And the only feature right now that it really is going to have that's cool is doing away with ads on YouTube. Now, I have no idea how content creators would get paid if they did this because, well, Google makes money when they play ads. If they don't play ads, I guess they're making money from the subscriptions to YouTube Lite. But it's a cheaper subscription. It's only like $5 less. Instead of being like $14.99, it's like $9.99. So, to me, that's not a good deal. I'm hoping that once they say they may add more features as they get closer. We'll see. But I would like to say, B&H Video, if you're listening, I just want you to know I'm tired of seeing the commercial about the couple from Alaska. They seem like really nice people. They seem really genuine. I like the fact they're taking pictures of bears. The population of the little town is only like 50. Yes, I've seen this commercial. It's like every time I go on YouTube, I see the commercial for B&H Video. I love B&H Video. I'm a customer of B&H Video. I've bought stuff from them before. So please do me the favor and stop showing me the ads constantly. And then, Mind Valley, you guys, do you really think I need to be a counselor for people? Okay, maybe I'm interested, but I don't even know how I got on your list. But literally, when I go on YouTube, I get two ads. It's either a video for B&H Video, I get their ad, or I get the ad for Mind Valley and how to be a life coach or a counselor through their whatever their program is. And so I keep skipping your ads when I can. Sometimes YouTube won't let me. It makes me sad, very sad, but I do the best I can. But I've even gone into Google Ads where you can go in there and supposedly tweak what companies can send you ads. You can say, well, so I went and said B&H and Mind Valley, don't do any ads for me, because you can customize your ads, supposedly. And it shows them to me anyway. I still get your ads. What's up with that? It does, yeah. So Big Red's asking, do Google and YouTube show you ads based on what you view on their platforms? And the answer is yes. It takes it and builds a pattern on you. And it says, oh, I noticed that you're between 35 and 55 years old. And based on your interests, you're probably male. And I noticed that you go and search audiovisual sites a lot, so you're probably interested in cameras or you're interested in sound equipment. And so it builds a profile, and based off of that, it shows you ads. And so it shows you ads based on the things that it has determined that you're interested in. And yeah, so, but you're supposed to be able to go and tweak that stuff a little bit and say, don't show me this, or don't personalize ads. You can set that up, and it doesn't seem to work. So I am sad. It used to seem to work. There for about a month, I didn't get any B&H video ads at all. And now I get B&H video. I bet if I went to YouTube right now and watched a video, it would be a B&H video or a Mind Valley ad. Either one of those two. So I'm just going to say, yeah. Fix it, YouTube. Fix it. Come on. Fix it. Fix it. All right. The last thing I want to do is stupid iPhone tricks. So, oh, by the way, if you have a really old phone, this is my PSA for this episode. If you have a really old phone, like so old Android phone that it runs gingerbread, well, after September 27th, you will not be able to log into Google anymore. Now, the odds of you having a phone that old, we're talking like Droid 4, we're talking an 11-year-old Android phone, the chances are pretty slim. But maybe your parents have that phone. Go take that phone away from them. Get them a phone from at least the last 5 years and they'll be fine. But don't let them have an ancient phone, because basically they won't be able to log in any Google services whatsoever with it. And an Android phone without Google services is pretty much just a phone. You have to talk to people and send text messages, but that's probably all you can do, assuming you can still do that. Anyway, all right, so tonight's stupid trick, I want to show you Google. So the other night I was Googling around. I'm on an iPhone these days, and so I started using Google search. And hang on, let's get the magic machine working here. Come on, let me join the party. Okay. Let's me type in a number. Come on, let's play. 6534. Okay. All right. So let's go to let's see if this is going to work. You're still zoomed in, huh? Here we go. All right. Cool. All right. 6534. Okay. All right. Come on. Display my phone. Display my phone. Display my phone. Display my phone. Come on. There we go. All right. Cool. So, hello. The other night, so I was using my phone, and I had the Google search app, so here it is, Google, and I went into the app, and there's no telling it's going to come up because it's stalking me, because that's what Google does. So if you go to the tabs button right here on the bottom, tabs, and then it'll show like tabs I've had open recently, so weather and the Bible website. If you scroll here at the bottom, and keep scrolling, come on, don't fail me, there's a pinball game. So now, when you're bored, there's nothing to do, play pinball. Yeah. I know I lost. There we go. Come on. Boom, boom. I know this is, why bother, right? But this is cool to me. I don't get out much. They don't let me out of the house. And so I just thought, wow, this is really cool. Yeah. And you keep going, and you play long enough, you get a high score. But, anyway. So there you go. There's your stupid Google search trick for today. Of course, how many have ever played the dinosaur jumping over the cactus, when he didn't have internet? That's also fun. But anyway, so there you go. That's the stupid trick for today. I was gonna keep playing, but you guys got better things to do with your time than to watch me play bad pinball. All right, that's a wrap. That's tonight's episode. Let's get my big ugly face in there and take the camera out of the way. Hello, phone. Let's stop playing now. On my screen, I have a giant phone in my face. But on your screen, hopefully, well, maybe you were happier if you had the giant phone in your face. But anyway, thank you so much for coming by. Thank you so much for watching. Like I said, be sure to follow me out there on social media as soon as things want to let me do that. Let's try it here. Yeah, okay. Nothing wants to play. Wow, that is fun. This is when good times happen, man. Good times, good times. Wow. Alright, we'll kill off. Let's do... I hate when it goes so crazy like this, man. Alright, so point being is, wow, that's really small. So anyway, I want you to subscribe to my channel, man. That's what I'm trying to tell you right here. Subscribe to my channel. I'll play it bigger this time, hopefully. Alright, so like and subscribe to my channel. Please leave a comment. Be sure to ring the bell. I really appreciate you guys. If you're rewatching this, thank you so much for coming by and watching this if you missed me live. This is the kind of stuff I do. I am tech news, reviews, and how-tos. And so there you go. That's what we got for tonight. I hope you have a great rest of your week. Thanks for coming by. Bye.